I'll share my screen. So we will start with the introduction of cloud engineering. Okay, exactly what it is and how it is actually benefiting the industries and why industries are actually uh, more attracted towards it. So see what cloud engineering is. Basically, it is on-demand delivery of IT resources or infrastructure over the internet on the pay-as-you-go basis. Okay. What exactly it means is like every whenever we develop a software, whenever we develop an application or some program, we need some resources to execute that. Those resources might be a network, compute engines, databases, compilers, interpreters, some security measures. It could be anything. Okay. Now, in traditional way, or if I say in a few years back when this cloud engineering was not in fashion, all these companies has to buy the licenses or purchases the servers or infrastructure for that. Okay. Now, what is the drawback in that case? Let's consider some project that wants to do some data engineering. Okay. And they would like to set up a Hadoop cluster. Okay, the technology that came into market a few years back. Now, if you want to purchase a Hadoop cluster, it will have some minimum amount. Okay, it might be some $1,000 or something. Now, to get approval of that, I mean, first of all, you have to decide what size of cluster you want. Okay, then you need some approvals from your higher management, and then you install those. Installation will take some time, approvals will take some time, estimations will take some time, budgeting will take some time, and we waste around minimum 2 months in this process. And then you purchase those things, you install those, and then the client says they don't want to give you this project to you. Okay, there's a scrap of that project. Now you lost your 2 months, you lost your time, you lost your money. Okay, so the solution for this is cloud engineering. In cloud engineering, you simply propose to client, this is what I'm going to give you. Okay, I work in a consulting firm, so this is something that we do on a very high frequency basis. We propose solutions to client. They look into those things. If they like it, they accept it. If they don't, uh, they simply reject it. Okay. But meanwhile, in this process, we haven't purchased any license, anything, and during this, if we wanted to do some POCs, we could do those POCs on rented basis. Okay, I mean whether it's AWS, Azure, GCP, some cloud we will choose as per the client preferences. We will perform the POC. If they like it, it's okay. Otherwise, we'll simply scrap it. So instead of buying, owning, maintaining those physical data centers and servers, we can simply go on a console, click, rent, and we pay the prices based on per hour or per minute uses, like making a phone call. And when we don't need it, we simply remove it from our consumptions, and we stop getting charged for that. This is the very very most effective reason that companies are moving towards cloud engineering, because it's reliable, it's secure, it's cheap, and it's transformative as well. Like nowadays, technology is changing every day, you can say. Okay, if you set up a cluster on a purchase license softwares, and if you want to move on to another, that it will take some time for you. Okay, you won't be too flexible to do that. But if you are on rented basis, you can rent some different technologies as per your choices. So this is what cloud engineering is. So as I've explained, cloud engineering has benefits such as it is agile. Okay, you can shift between technologies very easily. It is elastic. That means you can purchase as much as you want. If you want to have a 10-node cluster, if you want to have TBs of data to be installed, you can do it. If you just want to work and practice as a student level on MBs of data and just pay some pennies for that, that also you can do it. It does provide you some cost savings. You do not have to purchase, own, maintain, and be available for those security things. And it gets deployed in minutes. First, this is the most important thing. You do not wait for months and months to get approvals and budget and purchases to be done. As and when you get some requirement, you can click and you can start and you can deploy in minutes only. So this is what cloud engineering is. If you guys have any questions, you can ask me. Okay. So just one thing, moving ahead in the classes, I will be explaining topics. It might be possible that you guys don't get it. In case if you don't get it, please ask questions. If you don't, I'll have to assume that you guys are getting it completely. Okay. It might be a silly one, but definitely ask it. No issues there. And these are very basics that we are starting. First of all, we definitely need to understand, because see, when you go in project now and you suppose provide a solutions or you work on solutions, cost is very huge factor. I mean, nobody wants to pay more for something that they can get it less also. Okay, so we need to understand these benefits very carefully. Now there are some terminologies related to cloud. Those are infrastructure as a service, platform as a service, software as a service. Okay, these are the three major categories that we divide in, and this is not only for AWS. It is applicable also for your Azure, GCP, or any cloud that you name it. Now let's go through these categories. So infrastructure as a service. This basically means when you rent out some infrastructure from public cloud providing services, okay, that is called infrastructure as a service. Now, what exactly it means? So, you guys are actually working. If I remember correctly, all of you have some experience of 4, 5 years or 7, 8 years. Okay. So when we work, mostly we connect to some VDIs, to some servers, to some network machines. Okay, that is some infrastructure. Earlier, that infrastructure has to be set up in some data center by the company and maintained by them as well. But nowadays, you can rent out the same infrastructure, okay, over the public cloud. So when you rent out some service, okay, let me be very basic level. When you rent out some service, that service, if you can modify and customize, okay, I mean, let's say you are renting out a server. Server basically means a machine. I mean, some virtual machine, I will say, okay, some VDI, some virtual machine. When you rent out that thing, you can install software on that computer or virtual computer as per your choices. You can customize its security modules as per your choices. You can enhance or decrease the size of the machine, like in case of RAM, in case of its storage capacity. So when you have such flexibility, okay, when you have such flexibility, where you can rent out some infrastructure, modify it as per your choices, and then use it. In that case, that service is called infrastructure. In the AWS world, such services are EC2 machines. Okay, if you have if you have heard this name EC2, it stands for Elastic Compute Cloud Service. It is an EC2 machine. If you go on that machine, let me open the AWS. It will be easy to understand for you guys. Not sure whether my account is active or not. Okay, so this is our EC2 landing page. Do not worry about learning this thing. We will come here again. So this service basically allows you to, go ahead and launch a server for you and customize the server as per your choices. Now let's make it easy. When you click on launch instance, you have to provide some name. Then you choose OS type, whether you want a Linux server, a Mac OS server. That means if I say a virtual Macintosh laptop or virtual Apple laptop, Ubuntu server or Windows server. Okay, it is your choice of configuration that will be given to you. Let's say you choose Mac OS. Okay. Then they'll ask you exactly which version of Mac you need. Okay. So you get 13.5 is the latest. Then you have Monterey, Big Sur, or something like that. So let's choose the big latest one. So in this, you get 64-bit architecture, AMI ID, and then you can choose size of that machine. Okay, what exact size you want. Then you have sizes listed here. So this one comes with 12 core CPUs, 32 GB of RAM, and current generation. This is true. So if you choose this, you will get a latest Macintosh laptop that you can use virtually. Understand, physical hardware is, again, it's your personal laptop, but the server is of Macintosh, not yours. Then you have to choose some key pairs. That means ID, password, login settings, network settings. You can keep it to default as well. And you can launch this and start using an Apple laptop virtually from anywhere. You can have all the functionalities of Apple laptops and you can do your stuff. Okay. Just a side note, this is not related to data engineering. I'm just trying to explain you what infrastructure as a server means. Okay. So I'll wait here if you have any questions. Okay. See, if you get it, it's good. If you don't get it, it's okay. We will go through these things again and again in the classes. So this is something you will get very easily. Then we have platform as a service. See, in infrastructure as a service, we get some resources that we can customize completely, okay, as per our convenience. In the platform as a service, we get softwares, or I should say, we get some platforms that we can use as per our requirement, but we cannot customize those. Okay. So that example is RDS service. If I come here on the RDS, it actually means relational database service. Okay. Let's say I want to install a MySQL server. Okay. So I'll simply click on create database. I will choose my preferred server. It could be Postgre, MariaDB, Oracle, MySQL. Okay, I'll choose the MySQL. I'll choose its configuration, database name, ID, password, deployment type, and all those things I'll choose. Storage, I will choose what exactly storage I want in GBs. And then I can launch this. So this is exactly like having a MySQL server. In traditional days, you would have installed this on your machine, configured it, purchased the license, then started using this. Okay. And if you want to do it on production level, you have to purchase some servers as well. Now that all headache is actually gone. You can simply come here, you select the service, you select the size, you select security configuration, you launch it. In 15 minutes, your server will be ready. You can start pushing the data. You can start writing the queries over that. Okay. Why it is platform as a service? Because you're getting a platform. It is a database platform that you get and that you can use it. Okay. You cannot modify its configuration. You cannot modify its working type. You cannot install some more software inside that. So it is not completely customizable. It's like a in-between services where you can download them, choose the sizes and security configurations, and use it. Okay, this is your second category in platform as a service. Third one we have is a software as a service. Okay, in that category, basically, we simply get a software, something like Microsoft Teams, and we use that. We have no configurations or no customizations available there. That is a software, we can simply use it. That is a third type. Mostly in data engineering, you will work on type 2. That is your platform as a service, where you use AWS Glue, AWS Redshift, AWS Lambda functions, AWS S3, Kinesis, all this. These are all you can categorize in platform as a service, where you get a platform. That platform you can use as per your requirement. Different platforms provide you different functionalities and features. So again, I will take a pause here if you have any questions. So Karthikeyan, Aishwarya, Kanti.
We don't have any questions at this moment, Jalas.
Okay, good. Okay, one more very basic thing before we get started. Understanding the architecture of like how cloud is actually created. Okay, so be it Azure, AWS, or GCP, I am taking these three names because these are the three major public clouds and providing the services in ITs. See, when I come here on this screen and select a MySQL server and do all those configuration and click on create database below, okay, here, for us, it's just web clicks. I mean, we are just clicking and we are able to use the server. But an actual physical server is actually being launched for you. Okay, so understand this process. You are requesting a server access using a cloud platform, in the cloud console over the internet, but still there is an actual platform is being generated or actual hardware is being allocated to you. So how it is getting allocated? Okay, so for that, if you see what this cloud provider has done, they have created data centers. That means an actual physical location in some city. They have created some buildings where they have stored all the required hardware for these services. Okay, see, a cloud is not eliminating the hardware. Cloud is simply allowing you to not purchase, maintain, or adopt the hardware. You can simply work on the some console and use the hardware that is being stored in some location. Okay, now let's say, for example, we have a AWS region, AWS region in Mumbai city in India. So let's say at some location in Mumbai, they have this data center, okay, of AWS hardware. So what if the data center fails, maybe due to electricity failure, maybe due to some hardware failure, your services are gone. Like if you launch this, if you see this thing, there they ask you question, deployment option, single DB instance, multi-AG or multi-AG DB cluster. This basically means single DB instance basically means your database engine or your database hardware will be launched in a single data center in a Mumbai city. Okay. And multi-AG basically means your hardware will be launched in multiple availability zones in a single region. So what exactly it means? If you look into this picture, the basic unit, okay, the most simplest unit of the physical centers is data center. This is where they have their storage capacities, their configurations, their hardwares, okay. And in case of failures, let's say if data center 1 fails, all the services will be copied and made available to their customers via data center 2, okay. And this is called high availability. That means even if there are some failures, because failures will happen, there can be any reason for failures. There can be simply maintenance also, not only failures. It can be maintenance window also. And even at that time, customers want the services to be available. Okay. So they will serve the customers from a different data centers. So this combination where we have 2 or more than 2 data centers is called a availability zone. Okay. Or you can say vice versa also. Availability zone is a combination of 2 or more than 2 data centers. And the high availability will be called zone level availability for that service. Okay. For example, if you launch MySQL engine in 2 data centers in a single availability zone, like that means if you choose this option, okay, then it's called data center level availability, zone level availability. Okay. Sorry, it will be called data center level availability. Okay. But if you choose multi-AG, that means one of your copy of your data will be placed in data center 1 in this availability zone. They call it A, B, C availability zones like this. And the second copy might be created in a different availability zone. Okay. So if this complete zone fails, not only this particular data center, let's say, I mean, this first one has 2 data centers. If first one fails, it will served by second one. If second one also fails, then the service will be down. But if you have zone level, availability, then it will be served from a different zone. I mean, if the complete zone is down, still you will have the access to your services. That is called zone level availability. And the most highest one is region level availability. So region is a combination of multiple zones. At a single region, AWS region will at least have 2 or more than 2 availability zones. Okay. And region is actual physical location on this earth. Okay. We have in Mumbai, we have in Singapore, Sydney. Obviously, we have a few regions in US, Australia, like that. So all over the world, cloud services has created their regions. Okay. So when we say we want region level availability, that means even if all the availability zones inside a region fails, that means complete Mumbai region is down. That is very rarest of the rare case. It has not happened in the last 10-15 years. Okay. Only in the cases of tsunami, earthquake, that means, complete city is down, or war. In those time only, your applications will be served from a different region. You might back up the services in the different region as per your choices. Now, why these things are important, region availability zone and data centers? Because whenever we create a service, okay, even if you see this thing, some point it must be asking region. So if you see, right now I'm in Mumbai region. So if I click on create database, this database is going to be launched in some random availability zone of Mumbai region. Okay. Selecting the region is also our choice, and it depends on multiple things. Let's say my project is being launched in India, so I'll try to choose a region which is closest to my physical location. Okay. That means, we are all Indians here. So we will try to choose Mumbai region, or obviously US guy will try to choose their region that is closest to you. It's very easy. Just click on this drop down button, and you can see multiple regions listed here, and you can choose one of these things as per your convenience. Okay. So every resource that you create, be it simplest of S3 bucket or complex of EMR servers, they get launched in some region. That means these services are being actually getting hardware allocated from some physical location in this world that you can choose as per your convenience. Okay. So yeah, I'll pause here if you have any questions.
Hi, Jalaj, it's Karthik here. So I have one doubt, like, if you say the region, right? So the region is a place where the data resides, right? You mean to say that, or where the application get launched?
No, both things. If you
Okay.
if you launch a application, its all configuration will be stored on the hardware of that physical location. Even if you store the data, if you choose the particular region, it will store the data on that region only. And here also, some government policies also implies here. That is a very high level thing, not related to you guys, but it does affect that. Let's say China. Okay. China is a country, they have completely restricted their data to be stored in a region that is not in China. Okay. So if you're working on a Chinese project, they will not allow you to store the data on Mumbai region. They will ask you to switch to some Chinese region. That is for sure. Okay. And same goes for US or Indian, like EU. India might have some restrictions over the Aadhaar card data. They will not allow, like, if your project is working on Aadhaar card, GST, or some data that is very confidential to their own country. We will not allow the data to be copied into some US servers, or US will not allow such data to be copied onto Indian servers. That is obviously not related to us. These decisions are not taken by the data engineers or developers. It is mostly by the higher authorities in the project. But just giving you a hint. Yes. Any more questions?
Hi, Jalaj, this is Kranti. So who will give the instructions? Suppose, for example, if I want to deploy my application in Mumbai or Chennai, who will give the instruction where we want to deploy the application?
See, I'll say 100% of the time when it gets deployed in a project, the project has already identified its region. So they will let you know, your project manager, your team lead, those guys.
Okay.
And it's a one-time thing. Okay. So what projects mostly do, they will look to create all of their resources, store data, create programs in a single region. Let's say I worked with an Indian client last time. They have all of their data in Mumbai region only. And now I'm with
Mhm.
a US client. They have all their data in US East too.
Okay, okay. It depends on the client.
Yes, it depends on the client. And they will obviously, on day one, they will let you know in which region you have to, work.
Okay.
Okay. Now we will start with the first service. Okay, that is the simplest AWS service. It is called S3, Simple Storage Service. So I'll just open the PPT for that. Okay. So as a data engineer, first of all, we need to store data, correct? Now, where this data will get stored, okay? Or what is the idea behind this data engineering projects? Let's try to understand that part first, okay? Or why this data engineering came into the market, with such huge requirements. See, last 3 or 4 projects that I have worked, be it any client, okay, and these are all MNCs and CMMI level 5 companies. The tradition right now is companies are looking to save the cost. That is first thing. Companies are looking to manage their data easily. That is second point. And they are also interested in doing analytics. They want to understand their data and make some decisions on that data. That is third point. That is called data analytics. And they are also investing some amount in AI, machine learning, data science. Okay. For that, again, if you guys understand AI, you need to have a correct data at a single place. Now, if you, now if you see your current projects and current work, you might be working on some tools that they store data. Okay, and this data are stored on multiple places. Okay, if I give an example, last I worked with one very huge client. They had their data on SAPs, they had their data on network devices, they had their data on DB2s, mainframes, they had their data on some MySQL servers, hundreds of data sources, or I'll say thousands also, hundreds or thousands of data sources. And if I give you the recent example, I can take the client name also, that it's JNK Bank, because it's publicly available on the Google. If you type now JNK Bank RFP, you will get the link. So what JNK Bank is looking for right now, they have 30 TB of data on DB2. Now DB2 is costing them very huge amount. And when you execute some queries or when you want to generate some reports on DB2, it's very slow. It's very hectic to manage. That's why they are looking to move from such legacy servers to cloud. When we say move, okay, understand this part. When we say move 30 TB of data, we need to store at some location on cloud as well. Okay. Now that location can be of 3 types. Okay. The location can be of 3 types. Very similar words that you have heard. It can be a database. I'll open the notepad. They can move their DB2 to cloud. Okay. On cloud, we have 3 options. Okay. I mean, not options. Actually, these are 3 different use cases. But we will understand use cases. First, let's consider these things as an option. First is object level storage. Second is databases. And third is data warehouses. Okay. This object level storage is also called data lake. We are focusing right now on this part. Now, let's say if I want to store 30 DB of data on cloud, I have 3 options: data lake, databases, data warehouses. Okay. To move all the data on databases, if you guys think about this, what we have to do? We have to create the tables. We have to create the schemas. We have to create the databases. We have to create the data models. We have to decide the primary keys. Okay. We have to decide the foreign keys. We have to decide the SCD logics. We have to decide too many things if you're getting it. If you have worked on the SQL servers, you'll have to, you get these things, that to move a data from a place to a database, on it, be it Postgre, DB2, be it Oracle, MySQL, anything. We need to define the schema first, okay? And that is called your structured data, correct? Now, if I start defining all these schemas, tables, sizes, primary keys, foreign keys, data models, it will take huge amount of time. It might take a year or more than that. Okay, and we don't have such time. That is first complexity here. Second complexity is, if you see here on this page, right now I am requesting a single DB instance. Okay, I am requesting a 400 GB of storage on simplest of storage type. Okay, and it is giving me an estimate of, if you see here at the bottom, 564 US dollars per month. Okay, for 400 GB, this is going to charge me this. For 1 TB, it will charge around $1,000, and for 30 TB, it will charge around $30,000 per month, and that is a huge cost. Now, on the same time, if you see S3 pricing, okay, I'll let you know what the S3 actually is. If you see the pricing here, most expensive one is your S3 standard tier, and it charges you $0.023 per GB. Okay, I mean, if you convert this into TB, multiplied by 100, that means it's going to be $2.3 per TB. Okay, that means for 30 TB, you will be charged around $70 per month. Now see the difference. Here we are, it's $30,000, and here we are on $70. There's no comparison at all. Okay, why? Because S3 is an object level storage. Okay, S3 is an object level storage that allows you to simply dump the data over the cloud without any practical limits that you can use further in your projects to read or write the data. Okay. For now, you can compare S3. Okay, you can compare S3 with your laptop's hard drive. Okay, that basically means on my laptop's hard drive, I can store images, I can store videos, I can store files, I can store PPTs, Excel, whatever I want. Okay, this is what object level storage in simple terms means. A data storage that does not need any schema details, or basically does not need any information about your data. It simply can store your data for you. Okay, and that is what exactly S3 means. S3 is a simple storage service where you go ahead and simply upload your data to be used later in the project stage. Okay, you no need to define any table information, you no need to define any configurations, primary keys, anything about the data. You do not have to mention such way. It is cheapest option available on the cloud to store your data. Okay, so this is your S3 service. Now, first of all, I'll just take a pause here if you have any questions.
Hi, Shailesh.
Yes, Ashwarya.
Yeah, so here we are storing data, right? Is there anything like data should be specific type or it could be any of the structured, unstructured, any of the type?
It could be anything, Ashwarya. It could be even video games, videos, photos. It could be your files. It could be backup of your SQL databases. It could be anything in the world. Or if I should say, anything that you can store on a laptop's hard drive that can also be stored on S3 as it is.
Okay, thank you.
Yeah. I mean, if I give you a very easy option now, any cloud option that you see on your Android phones, like Google Storage, OneBox, Geo Cloud, whatever you see on cloud storage, it is all object level storage. They are not using it for IT resources. They are using it for general public access, like your shared drive, your Google Drive, your Google Photos service. It's all object level storage. You can dump any data that you want, and it's the cheapest of the storage option available on the cloud. Okay. So basically, nowadays every project is, as I mentioned, J&K Bank, every project is looking to get their data from the legacy services to S3 like services. Okay. They land their data here, and then we start data pipelines that we will learn in this course in phase-wise manner. Okay. So this thing you should keep always in your mind. The first choice of data storage. Whenever there is a migration project, first place to store data, first place to land the data is always going to be your object level storage. This service on AWS is called S3. The service on Microsoft Azure is called blob storage, or ADLS, Azure Data Lake Storage. The service on GCP is also, I mean, I'm not remembering its name, but they also have the same service. Okay. Now, what are the features of S3? First of all, it's object level storage. That means, in simplest term, any data can be stored. It's okay. Second is it's scalable. You can store KBs of data. I mean, just one file or a few photos, or you can go beyond and store petabyte level data also. Practically, there is no limit. This is what AWS says, that practically you cannot consume all the space on S3. This is what they say. Okay, it's scalable, and you are only going to be charged for the amount of data that you store in that particular month. Let's say I store 10 TB of data in this month, I'll be charged accordingly. And in next month, I store only few gigabytes of data, I'll be charged accordingly. Okay. Then they say high availability. As I explained just before, high availability means when you have multiple copies of your data or of your infrastructure in different data centers and in different availability zones. Okay. By default, S3 provides you 3 copies of your data. Okay. They provide you 3 copies of your data. One copy will be stored uh, in one data center. Another copy will be stored in the same availability zone, but in a different data center. And the third copy will be stored in a different availability zone in a single data center. So this is how we get 3 different copies to be stored here. That ensures if the complete availability zone goes down, still you have the access to your data in a via different availability zone. And see, guys, this is not a daily happening things. Like even in a years of years, you will not see these things happening. But just to ensure, because we might have banking data, we might have financial data, we might have PII data. So we cannot lose that data. That's why we have multiple copies of data available on the internet. Then obviously security. If we have such personal and such confidential data, we should have some security features enabled. And obviously, do not worry, we will see these things practically as well. Okay, only today I'm just giving theories. And then performance. Performance in the sense, let's say you use S3 for your reading and writing purpose. Okay, let's assume a Python program that reads from a SQL database and writes a table into SQL database. The same thing you can do with S3 also. You can read a CSV file, you can write into a CSV file or Parquet file or JSON file, whatever format it is. And it is not going to give you any sort of degraded performance. It is not going to enhance the latencies of your programs. That is one thing S3 ensures. Okay. Now just look how just have a glance at how it exactly looks like. I'll come here on this page. I'll go on S3. Just type. I'll just redo it for now. Just see it. So if you see one of the examples here, this is one of the bucket. We will discuss all these buckets and these things, each of these buckets of everything I'll be showing you practically in tomorrow's class. But now see here, I have this bucket. You can consider this as a D drive. Okay. Inside that I have multiple files and folders. You can see I have a folder here. Like when you have a forward slash, that means folders. Even in the type, you can see it's a folder type. I have a CSV file. I have my Python program here. I have my PPT here. It's just like data is being stored here. Okay. Now let's do one small practical. Let's try to upload some data. All you have to do is click on upload button, add files. Let's say I want to, upload my certificate here. I choose this PDF file. Okay. It clearly mentions its type of PDF file. Simply come down, click on upload. Now I have a copy of my data available on AWS S3 service. And you can see I have multiple folders, multiple file types, all these things are here. If I sort it based on last modified, I'll see my certificate here. Okay, just a very small glimpse I'm showing you right now today. We will do a complete practical hands-on in tomorrow's class. We will understand all its features, its storage classes, and how exactly it is benefiting the clients. So I'll take a pause here. If you have any questions, you can let me know. Okay. In this case, if you have any questions, we'll meet tomorrow at the same time. I'll be sharing the PPTs via emails to you guys. Ganesh will collect your email IDs. So don't worry about that. All the codes, all the PPTs, all the recordings will be shared by Ganesh to you over an email or on the shared drive as well. And as I mentioned, if you have any questions, don't hesitate in asking those questions. We are here to learn. So one more time, if you have any questions, you can ask me. Otherwise, we'll meet tomorrow at the same time.
So any questions, Karthik, Aishwarya, and Kranti Kumar?
I'm good.
Okay. Aishwarya? From your end, anything?
No, I'm good.
Kranti? Sure, then. See you tomorrow at the same time. I'll create WhatsApp group and I'll send you the invite.
Yeah. Thank you, guys. Bye-bye.
Thank you. Thank you, Jalash. Thanks for your time.